Welcome to my presentation. My name is Ozan. I am PhD student at Ankara University. Today I am going to talk about sample geometry and the rotation effect on the temperature uniformity during microwave thawing process. Microwave frequency is between 300 MHz to 300 GHz, but only 950 MHz and the 2.45 GHz can be used in the food process. We apply thawing process to tylose by microwave technology. We choose thawing process because dietic properties are significantly changed between frozen and the unthawed part. Microwave is provided to reduce the process time and to improve sample quality. Microwave, known as the volumetric heating, which is dependent on the electromagnetic distribution in cavity and dietic properties of sample. In this study, we focus on the sample geometry and size and the rotation effect on the temperature uniformity. Various shapes were used in the model. All of them have same volume. Domestic microwave is used in the model, and you can see the dimensions. Three different configurations were examined to how to affect the temperature distribution. These are center without rotation, center with rotation, off-center with rotation. This is the mathematical model plan. Tylose was chosen as a food sample. All models were carried out in the Computational software. Microwave heating model was used in the model, which is contained in electromagnetic waves and heat transfer in solid. As you know, domestic microwave oven usually works with the cyclic power mode, but we used constant power to clearly see the rotation effect, and we applied 300 watts. All walls are selected to perfect electric conductor. Walls reflected the electromagnetic waves. You can see the initial and the boundary condition in heat transfer. Electromagnetic waves and the heat transfer are combined under the multiphysics by heat source. These are the energy equations. Rotation effect is applied on the moving mesh model. Cavity and the sample are defined as a free deformation. This velocity equation, this is the velocity equation on the feed direction. By this equation and the automatic remesh, our rotation is the continuous during process. Most of the study are used mesh displacement, which is a step-by-step rotation. Cavity and the sample mesh size. Mesh gravity was checked by the Nyquist equation. Results. You can see surface and the slice temperature distribution for center without rotation and the center with rotation. Rotation is really effective on the temperature distribution. Center with rotation, sample side surfaces are exposed to different intense electromagnetic distribution during the process, which has improved the temperature uniformity. And total power absorption of the center rotation is fluctuating during process, and this is the proof its sample side surfaces are exposed to different electromagnetic distribution. Same results can be observed in the Prisma too. Cylindrical results for center without rotation and off-center with rotation. And you can see the gives for the three cases. Sample was changing place by volumetric during the process in off-center with rotation, and all surfaces are exposed to different electromagnetic distribution during the process, which is really improved the temperature uniformity. But in center with rotation, sample doesn't change location during the process. Only side surfaces are exposed to different electromagnetic energy. And total power absorption of off-center rotation more fluctuating, and this is the proof sample is exposed to different intensity electromagnetic distribution. Surface temperature distribution. Off-center with rotation is really improved the temperature uniformity. Spherical results. Top part of the sample is cold spot because of the electromagnetic distribution in cavity. So sample size, especially height, is really important parameter to get the uniform temperature. These are the gives for spherical, and same results can be observed. Surface temperature distribution. In this study, we showed uniform temperature distribution depends on the sample size and shape and sample location in the cavity. And uniform temperature is improved with the rotation, especially off-center rotation. But food industry prefer the microwave tunnel instead of the domestic microwave oven. And sample is moving straight on the conveyor belt in the tunnel, and electromagnetic distribution depends on the magnetron location and the number of the magnetron. 950 megas can be used in the microwave tunnel for the higher wavelength, and big samples can be processed in this frequency, and multi-sample samples processed simultaneously in the microwave tunnel. But there are some problems. Mesh elements really increase too much. We need higher computer power, especially RAM. And one model, it's take too much time. We have already started the computational studies on microwave tunnel, and it took more than 1 month. And thank you for listening to me. Thank you.